So Dr. L.R. Manjunatha is a prominent civil engineer and academician, specialization in sustainable cement and concrete technology, with a career spanning 3 decades in the concrete and construction industry, focused on developing green building solutions. He serves as the Vice President and Head Business Development, JSW Cement Limited, for winning and developing ecosystems for large-scale infrastructure projects, government department specifications, housing project specifications and approvals, and also focusing on new marketing, development and acquisitions. Educations and academic involvement. Sir Manjunath sir holds an PhD, an MBA, BE Civil Engineering and a MPhil, and is an alumnus of Bharatiya University. He was a honorary chairman of Indian Concrete Institute, Bangalore. Uh, he is a qualified certified concrete technologist from City and Guilds London Institute, UK, and Concrete Technologies of India, CTI. He is a qualified independent director for the Indian Institute of Corporate Affairs, a division of the Government of India. Coming to career achievements and contributions, he's an innovator in sustainable construction. At JSW Cement, Manjunatha champions the adaptation of eco-friendly building materials, including low-carbon concrete and other sustainable technologies among government infrastructure projects, RMC, and building segments. Coming to the industrial leadership, he has served as a technical mentor to many universities, engineering colleges with more than 800 technical lectures and contributed intensively to scholarly articles that have shaped the cement and construction industry. Honors and awards. His contributions have earned him several accolades, including Eminent Engineer from the Association of Consulting Civil Engineers 2022, Technologist of the Year from the Construction Industry Development 2022, National Award for Excellence in the Sustainability in Construction 2021, and Concrete Technologist of the Year from the Concrete Engineer Association 2023. Sara has published more than 75 articles on concrete technology, focusing on topics like green concrete, use of supplementary cementous material for long-term durability. With this, sir, thank you, Manjunath sir, very much for kindly gracing this.
Thank you, thank you. It's a great honor. Vizag is a city I always love. I used to come for
Yes, sir.
business trip for RMC
Yes.
way back somewhere in 2010-11. I was coming. Wonderful city, clean city, having very good coastline, and now it has become the hub of innovation data centers for the AP government. It
Yeah.
is like Silicon Valley of India. Very great to see such a beautiful city shaping, and Gayatri University also is there. You must have visited the university long back. I don't
Yeah, yeah,
recollect.
yeah. Some 7, 8 years back, while you were in Ultratech, I remember, sir, you have visited and given us a lecture
You
outside.
delivered the
No, thank
lecture
you.
also, sir. You have delivered the lecture also
Yeah,
when in 2013 or 14.
Yeah,
yeah.
yeah. Yes, sir. Yes, sir. I remember, recollect it.
Yes,
Recently,
sir.
I've
Professor
got
Professor Veerabhadra Garu and you both were there associated together at that time, I think, sir.
correct. That great memory is there with me always. Today, my dear faculty members, consultants, professionals in the construction field. Earlier, way back when we must have all started our career, we were only talking of making M15, M20 grade concrete and maximum M30 grade concrete. So, but the days have evolved now. Mumbai, I'm now based at Mumbai. I shifted to Mumbai here from Bangalore. The grades of concrete is M100. The specifications they're talking about is RCPT value below 500, then water per impermeability below 10 mm. The specifications are changing now. Then they're talking about how much lesser cement we can use, because 450 kg cement is the maximum cement content we can use. When we design M70, M80 grade concrete, so you are limiting the cement content maximum to 450. Balance will be either GGBS, because GGBS also very famous in Vizag, because the steel plant is there. Then fly ash. Then there are ultrafine materials like microsilica, ultrafine GGBS, and other input materials are available. So, uh, At that time, the concrete was only a mixture of cement, sand, aggregates, water, then a least admixture we were using. But now, concrete, if you are making an high grade concrete, M70, M80, M100, then there are so many parameters are coming. Now, as per the new IS 456, which has been now being circulated, they're talking about high performance concretes, high durable concretes, then RCPT value, RCMT value, sulfate resistance, chloride resistance. Then now the zonal regulations of the earthquake zones also in India have changed now because of the earth strata changing. So we have a complex types of design now. When you want to design a building, you have to first tick mark, okay, whether wind velocity is there. Like every cyclone came and affected the Vizag city some 2-3 years ago. Many structures were uh, came on ground because of they could not withstand the wind velocity. So we have to design the highest wind speed because many high-rise buildings will be coming in Vizag, just like Mumbai. Mumbai building 200 floors has become common now, almost. So all these things should happen with a low carbon intensity. Why low carbon intensity is very important? Because every ton of cement, when we want to make cement, our main raw material is limestone. You all know. We are going to consume 1.23 to 1.5 tons of limestone. Then we are going to consume coal, electricity. For making 1 ton, we require up to 80 units of electricity, kilowatt hour. So emissions related to CO2, every ton cement, the emissions are up to 800 to 1000 kg. So that means to say every ton, like 20 bags of cement, if you are using, you are emitting 1 ton of carbon dioxide. 1 ton carbon dioxide remains in the atmosphere for 300 years, not today. So we may think that, okay, I will plant trees, sir. Everywhere we are planting trees and all. Trees will be able to absorb carbon dioxide. So every tree, a fully grown up tree, can absorb only 22 kgs of carbon dioxide per year, one tree. That means to say, so how many trees you have to plant? Huge number of trees to absorb 1 ton of carbon dioxide. Almost 45 to 50 plants you have to plant. So if you are planting 100 trees, 50 plants may survive. So that means to say it's a very big work. And meanwhile, you will not be able to plant so many of our trees because land is not available. That is also a challenge. So these are all the various challenges in the construction. So if you can reduce the carbon emissions while doing construction alone, because we are all civil engineers and we are teaching thousands of students, we are practicing also as civil engineers. And our responsibility, like how much reduction I can do when I'm making concrete. Okay. So there are many ways actually. You can adopt blended cements like slag cement, which carbon intensity is very low. You can use PPC cement, which is available widely, Portland Pozzolana cement. Instead of using, if you are using a small construction, you should never use OPC cement. Then if you are using OPC cement in the RMC batching plants, you can blend it with fly ash, GGBS, high-grade concretes are there, you can blend it micro fine materials. So these are the various means of reducing the carbon footprint in the construction. So already I've discussed these points. So what is low carbon concrete, sir? So earlier somebody is using fly ash and all, we used to tell, oh, concrete is used, people are using fly ash. I still remember I was in the RMC Remix India. If you are telling fly ash, they used to say, what you are adding ash to the concrete. We want pure OPC 53 grades cement concrete. We don't want any ash in the concrete. So you are deteriorating the quality of concrete. That was the questions being asked. So, but now those concretes are well adopted, well accepted throughout the world. They are called low carbon concrete, but without affecting the strength, the durability, performance. In fact, better strength, better durability, better sustainability, better reduced life cycle cost. These are the various new terminology being adopted for low carbon concretes. So they are safe, they are highly durable, they are economical in terms of cost benefit. So when we look at the ESG values, okay, so we look at how it is cost effective, how it is durable, how it is sustainable, and how you can reduce the life cycle cost. These are the various aspects we look into that. So how to make low carbon concretes? I told you the first principle is to reduce the cement usage in the concrete. So how can we reduce the cement usage in the concrete? By adopting blended cements, by designing concrete mixes very efficiently, particle packing, overall cement content we can reduce. Then, while cement manufacturing itself, using alternative fuels like municipality waste, RDF, fuel efficiency, reducing the thermal energy requirement for the cement making. Then there are so many other methods like recycling the same heat. Okay, so that is also very popular now. The technology in cement factory. So cement factories now, with all the difficulty in making OPC cement, they are able to reduce the carbon emissions from 1 ton to 740 kg. In that level, they have reduced. We are making a pure OPC cement, so the emissions are 740 to 750 kg. Then, if you're using a blended cement, if you're using a PPC cement, it's about 540 kg. And if you're using a slag cement, where you can replace the clinker by almost 50 to 70%, then the emissions are further coming down. So, adopting the kind of cement makes a very important decision. Then now the new calcined clay cement, also new code has come. Some companies have started manufacturing. That also may become a benchmark now, using calcined clay. Okay, then using recycled aggregates. If any old buildings are getting demolished, by processing it, old debris, we can get aggregates, we can get sand, sand, we can get CND waste. Okay, then using high performance admixtures. High performance admixtures help in reducing the water demand. Self curing admixtures, highly water reducing admixtures. When you reduce the water cement ratio, naturally the strength will go up. That is the advantage of the product. Then there are carbon cure technologies by injecting carbon dioxide in the fresh state of concrete. Okay. So here you're converting calcium oxide to calcium carbonate, which is going to be a solid material. These are various solutions we are getting in the low carbon concrete. So how the low carbon concrete globally is taking shape? So how it is affecting? Because being in Vizag or some other city, you may find that okay, this kind of intensity, the measurement of low carbon concretes are not there. But globally now, go to European countries, America, they will mention like the World Trade Centers like brought down by the terrorists, and a new tower has come there, near World Trade Center. So there they specified the business center. You have to design M80 grade concrete, but your cement content should not increase 230 kgs per cubic meter. Whatever you want to do. So that was the specifications for that tower. So the companies which designed that, they went for a GGBS fly ash mix along with a microsilica content, where they could get that M80 strength. Okay, and could build the structures. Now, so those kind of systematic regulations are coming, where the demand is very high. The grade of concrete is very high, but you cannot use a more higher cement content because they want to bring down the emissions in the concrete. So when we make concrete, there are two considerations. One is the supplier consideration, the buyer considerations. Okay. The concrete companies like RMC or anybody who are making, they want a better pricing and adaptability. Okay, good supply chain system they want. Buyer consideration. Whenever a builder or a developer want to buy concrete, I still remember like the Vizag, even though the ready mix plants were there, they were not using ready mix concrete. They wanted to go with a site mix concrete. The builders, small builders, they want cost efficiency and green label product. So many reputed builders and developers, they want low carbon concrete, value for money, not at increased cost. These are the various. So government is playing a very important role now. Standards are coming. National Building Code is coming. Then we have new IS 456, new IS 383, where I'm part of the committee. They all are coming now. They're changing. So IS 380 now adopting the higher percentage of CNT waste. Okay, recycled aggregates usage. All the codes and are now allowing the usage of cementitious material. New IS 456 allowing composite cement, blended cements, then uh, other types of cements. Many types of cement which are having low carbon intensity, they are being allowed to be used in the concrete making. So we need to work very closely. So there's an increased demand for low carbon concrete. As I told you now, if you are saving 1 ton of carbon dioxide in the concrete making in Europe, you are being provided a $100, 100 euro. 100 euro is the incentive for you. So that means to say almost 9,000 rupees is the incentive to you if you are going with a low carbon concrete. So coming to JSW Group, we are one of the largest steel producer in the country, and we have huge capacity of steel, and cement is the one which is fastest growing cement company in India. Currently, we have got 21.6 latest figure millions and capacity. We are going to be very soon 40.9 million ton by 2030. That is our goal to reach the higher growth. So we have paints. Recently, we have acquired AkzoNobel India to be the third largest paint company. Then we have infrastructure. We are having ports near Paradeep. Then we are building a new port in Paradeep. Then we have ports in Mumbai, Jaigarh, and other places. So our port capacity is also increasing. Sports, we have many sports ventures. We have Delhi Capitals co-owners, Haryana Steelers, Bangalore Football Club, and also through Inspire Institute of Sports, we are supporting the developing new champions for Olympics. These are the various verticals of JSW Group. Recently, we have entered into even JSW Motors also, where MG Hector, we are the joint partners with MG Hector. We have launched a new vehicle, Windsor, where battery as a service. No other company is having that kind of a new system where battery, you don't have to own the battery in the electric vehicle. It's owned by the company. So coming to the conservation of resources, we are trying to utilize all our byproducts. Like we generate electricity, we got almost 6,000 megawatt of thermal energy, where we get fly ash. So we have got almost 37 million ton capacity of steel, where we get slag. So both the products were laying idle, and we are utilizing these products effectively to make low carbon cements, low carbon concretes. So our main mantra is to adopt philosophy of aligned growth using circularity, reuse, reduce the waste, reuse the waste, byproducts, recycle the byproducts, and always think with new innovative ideas, new products. So circularity is our philosophy. In that, so as I told you, we are adopting many green initiatives to develop new world-class products using technology, using innovation. So those products are global benchmarks, which can be adopted to develop low carbon concretes in India to make the world green. This is the product portfolio. You can see, even though we make OPC cement 4353 grade to support our initiative to give all the materials to the customers, our 85% of the product portfolio is completely green and sustainable. We are the largest producer of slag cement in the country. We make composite cements, we make blended cements. Also, we make ready-mix concrete, low carbon concrete, ready-mix concrete. And our flagship products are GGBS and microfine GGBS. Both are adopted almost everywhere in India. So this is our company footprint. Don't spend much time on this. So we are present everywhere. So carbon emissions, as I earlier explained you, to make 1 ton of clinker, almost 925 kg of CO2 emissions. Energy conservation of close to 3,895 joules per ton. This is the energy requirement because the limestone goes through a process. First, we bring the limestone, we mix other additives, clay, alumina, silica, iron oxide, and have a raw meal, grind it up to 1400, heat it up to 1450 degrees centigrade with preheaters through kiln. Then we get clinker, grind the clinker, add gypsum, and we make cement. So that's how the cement cycle works. So sector-wise emission, if you take, sir, the highest emissions come from the transportation sector, energy sector. And we have cement, we have steel, various sectors contributing emissions. Mainly the power sector with the oil, coal, gas, that will contribute to the highest emissions. So coming to the construction industry, as I told you, the energy consumption from the construction, building, construction, operation and maintenance is about 40%. So once we construct the building, it's not over. We have to maintain, operate, AC systems are required. And many buildings now, many campuses and all have various types of system maintenance systems, HVAC, everything is required. So emissions are about 30% and global dust. So construction alone not only leads to emission and dust, the particulate, PM 2.5, PM 10. These are all worst disasters. When the winter time comes, we always struggle. Air quality index in many cities now it is deteriorated completely. Almost 150 to 200 air quality index is coming. So because of that, people are not able to breathe properly. These are the various aspects during the winter season. So we need to really think why it is happening like this. Like a city like Delhi and all, they close the schools for almost 10-15 days because air quality index is poor. And like we need development, we need growth. Being India, one of the fastest growing economy in the world, third highest, we're going to be third highest economy now. Very soon, we are overtaking Germany or Japan. When it happens, so we need development, we need growth, because at the same time, we have to keep our environmental conditions safe so that our next generation will be very comfortable to live on this planet. So expectations are there, like various stakeholders are there. We have our clients, regulators, developers, and concrete producers. So everybody having their own requirements. So any construction field, we have clients like builder developers and all. They want IGBC certification to all their buildings. They want cost reduction. They want a better finish, faster construction. Then we have the regulators, government agencies. So they're looking for adopting the policy implementation. Then they're looking for SDG goals. There are 17 sustainable goals are there. They're looking at, and they are also having a target by 2070. The government of India has a target to move to net zero. Okay, these are the targets. So developers are also having target. They're competing each other in terms of pricing, in terms of regulation, in terms of better quality finish. So they are looking at economizing the concrete of construction, cost reduction. They want to reduce the size of the structural element like columns, beams, many things. So concrete producers, RMC companies, they want the approvals of the client, right product pricing they want because they should be sustainable. They should be able to provide a good quality product at the right price. And market acceptance also very important. Then there are structural consultant and professors. Many projects may be coming to your college for approvals on mixed design and other things. So you also evaluate based on the specific requirement of the client. So coming to the concrete composition, so as I told you earlier, concrete was a mixture of only 4 to 5 ingredients. Mainly it was cement, aggregate, water, admixtures. But now the concrete philosophy is changing, as I told you. So the new IS 456 draft code, now it is on the exposure condition itself, they have got a various now classes. To understand, to educate the people is very important. So we need to really work on that, how we can take it forward. So it clearly says that the adaptation of sustainable SEMs like fly ash, GGBS, slag cement, PPC, it's always there in the code, and you can adopt them very comfortably. So many clients or other people will keep on telling, no, I want only pure OPC cement concrete. I don't want any blending. But we have to teach them. We have to make them to listen. But see, we are giving you same quality, better performance, better durability, at a bit reduced cost. So why should not you accept this new type of concrete with a blended cement or a SEM instead of going for a pure OPC concrete? So I hope and this will be very useful to all of you. I'm sharing the PPT also. You can go through that leisurely. So when you are becoming a designer or a consultant, you want to teach the students, you have to basically make them understand what is important, what is the need of the hour for the country, for the concrete technology. That's very important. And we need to provide proper solutions and make them realize it may be one call, two calls, three calls, whatever be the number of calls, we can convert them. So meanwhile, durability parameters are coming, sulfate and chloride resistance based on the environmental conditions. We need to really work very closely. What kind of cement and what kind of a blended mix of OPC, GGBS or fly ash will be effective based on the sulfate resistance and chloride resistance. So as I told you, we want so many things from concrete. Okay, even though concrete is an inert material, but it's not an inert material. It is a very active material. It will keep on hydrating even after 1 year if you are using a mineral admixture like a GGBS or fly ash. So when we make concrete, the initial workable stage, it should be highly workable. That means to say, should be able to flow freely and should not segregate and bleed. Okay. So workability is very important. Compressive strength is important. Durability and the dimensional stabilities are important. Okay, we're looking for a dimensional stability and durability. These are all very important for a concrete structure. Sorry. So challenges in the concrete fresh. Okay, when we make concrete and all, we are going to get a lot of challenges. Whoever is making concrete and all, definitely we are going to get many challenges. Challenges in the form of, okay, when you make concrete, mainly concrete workability is very important, and shrinkage cracks, plastic shrinkage cracks. So we need to avoid all these things. So in practice, ideally we need a perfect particle backing, but in practice we get excess water, bleed, compaction. However, maybe the thing, if you're not coming from a ready mix batching plant, a good quality ready mix batching plant, if you're making concrete at site, whatever may be the thing, it will be affected. It will be affected a little bit. So we need to really work the fresh state of concrete. So when the concrete is hardened, okay, concrete is set, we are looking for a reduction in the shrinkage cracks. Ingress of external aggressive agents, voids is very important. Okay, so need to really work very closely with making concrete. Free water demand, excess cement content. So when we designing mixes, how to regulate the water content, and also the degree of hydration, water cement ratio, these are all playing a very important role. So as I told you, the enemies of concrete are many. If you're not able to make good quality concrete properly, then you're going to have various enemies. Enemies in the sense like, okay, the various agents which are going to attack the concrete. So we have mainly moisture, okay, concrete exposed to moisture. When the structure is made, definitely there's a rainfall, there's a wind, the moisture will enter the concrete. Okay, then we have sulfates entering the concrete body, soil. Then chlorides through soil, it will enter the concrete. Then carbon dioxide. The vehicle population is increasing in every cities. The carbon dioxide emissions by the vehicle will also enter the concrete. So with all that, then alkali silica reactions with the aggregates are very reactive. then ASR is very important. It's going to play a very important role. Then you need to really design the concrete. So concrete now no longer just like that 1, 2, 4, 1, 1.5, 3 make concrete. That is not going to work. The concrete which is going to work is properly designed. We have a proper mix design. Everything has to be perfect. Then only that kind of a concrete only can work for any kind of a situation. So concrete the durability, as I told you, concrete has to be durable. Okay, because when we make any building structure and all, like we are looking, okay, building should last as much as possible, and we are not demolishing the building. We want it to last generations. Okay, it is being built unless somebody comes and demolish the floor area, FSA changing, higher floors are permitted. Nobody would like to demolish the building, or you want to go for a redevelopment. Mumbai, about 40,000 apartments are under redevelopment. Because Mumbai, the coastal area, like Vizag, the buildings are subjected to various weather conditions. Okay, rainfall, heavy rainfall, then resistance, sulfate chloride attack. All these are quite common. And building comes for redevelopment. Now there are 40,000 apartments going for redevelopment in Mumbai. So this is very important. So how we can design the buildings? Okay, so the concrete should be able to withstand both physical deterioration, attack on physics of the concrete, external agency, and chemical attack, where the correction of reinforcement will take place. So we need to really work very closely from the design aspect, how we can make the concrete highly durable for both physical deterioration as well as chemical deterioration. So mixed design, we have to give very importance, as I told you. Water cement ratio is very important, and having a the blended cement or a cementitious material is very important. What kind of cementitious material, either using fly ash or GGBS or blended cement, is very important. There are many mineral admixtures. So quite commonly available are fly ash is available in Vizag, GGBS is available. Metakaolin is not so popular because here also you want to make metakaolin, you need to have a clay heated up to 1600 degrees centigrade, China clay. So microsilica is quite popular. It comes imported from many countries like China, and it comes from Norway and other cities. Other country outside, we don't make microsilica here. So we generally make GGBS and fly ash here. So these are very important products. Just let me have a water, 1 second. Sorry. Okay. So how the slag, basically slag, you all know, you have a steel plant in Vizag, blast furnace slag. How it is being manufactured? It comes from blast furnace. We have iron ore, coal, lime, all come as a flake in the blast furnace. So here it is heated up to 1500 degrees centigrade. Then we get high quality iron. Then 30%, almost 30% we get as a slag. It's called blast furnace slag. Blast furnace slag, it's rich in calcium silica aluminates. So it's having a very good product mix. Both calcium oxide is there, silica is there, alumina is there. So that's the reason it is very good for as a cementitious material. So once the blast furnace is taken out and quenched into small granules, that granule, after removing moisture, Then we have a grinding, vertical shaft grinding mill or a ball mill. You grind into fine powder. That's called GGBS, ground granulated blast furnace slag. That can be blended along with OPC cement to make slag cement, and otherwise also that GGBS can be sold as a separate product. IS 16714 has the permission to be sold, and we have been selling this product almost close to 6 to 7 million tons every year to many RMC plants, where they blend the GGBS along with the OPC cement. They make the concrete, starting from 25 to 50, 60% they have been using continuously. So this is the GGBS. And we are the pioneers. So as I told you, the slag, because of the advantage of calcium, silica, alumina present in excess, very good quantity, it's a cementitious material. Apart from that, it's amorphous in nature. Glass content, we're talking amorphous reactivity index. So the slag, what we are manufacturing, almost 95% reactivity content is there. So it makes the slag super reactive when you add it with water, along with the cement combination. So this is the GGBS. You already may be knowing in Vizag, GGBS is being used extensively in all the RMC batching plants. So why GGBS is important is that, as I told you, when you are making cement, your emissions are very high. So almost 850 to 950 kg emissions are there in every ton of cement you are making. Whereas already the GGBS has suffered this emission, the steel manufacturing process, only the grinding. It was a waste material being dumped in the site. So that material we are taking and grinding into fine powder. So the emissions are closely 60 kg per every ton. So if you are using GGBS almost by 50%, you are reducing the CO2 emissions very effectively by almost 50%. So not only it's reactive, this is double reactive. The reason behind, when you add water to OPC 4353 grade, you will get two components. One is the CSH gel formation and also the calcium hydroxide. So calcium hydroxide is about 26% that is present in the concrete body. Then about 50-55% we get CSH gel. And balance is the whites and yttringate. Okay. So what we have to do now, we have to convert this calcium hydroxide into more useful product called CSH gel. More the CSH gel, more the particle packing will happen in the concrete. So the advantage is that when we add GGBS in the concrete matrix, it having three components, GGBS, alumina, silica, and calcium oxide. Calcium oxide directly contributes as a cementitious material in enhancing the CSH gel. Then alumina, silica, they all work with calcium hydroxide, a pozzolanic material, convert calcium oxide further to CSH gel. So hence, we have a robust concrete structure which is highly durable. Increased durability, increased long-term strength, and also better particle packing. These are the various new points you are going to get by adding GGBS in the concrete. I can show you here like the first, this is without GGBS. A lot of whites are there. And here you can see this is a slag-based concrete matrix, where the interfacial transition zone, it's always occupied with the hydrated product, CSH gel. So advantages are many. Advantages like we have GGBS as a product, resistant to sulfates, chlorides, reduced heat of hydration, especially for raft foundation. You're designing a building, 2.5 meter raft, 3 meter, 4 meter raft. So you are going to have a very good concrete with a temperature gradient less than 20 degrees centigrade, because that is very important. Temperature gradient is very important when you are designing a raft foundation. So GGBS plays a very important role. Like now recently the Amaravati capital, Andhra Pradesh being built. So we had supplied GGBS blended concrete for the HOD towers. There, the concrete was submerged in water for almost 5 years. Government changed and the capital development did not happen. So after 5 years, I'm giving a live example of your Andhra Pradesh only. After 5 years, so IIT was appointed to study the concrete durability, whether same foundation can be used because it was submerged in water. Then they completely studied, and there was one foundation which was 60% GGBS. So they studied and gave a report that nothing has happened to the concrete because of usage of GGBS in the concrete, and nothing has happened. Same foundation can be used, and the structures can be built 33 story. So imagine we had to remove the entire foundation and redo the foundation. Uh, Not only cost, removing itself would have been much more difficult, almost 5 meter raft. So using GGBS in the AP, Amravati capital, long ago has really helped them now. And the same structure, they are rebuilding the towers, and that will be the capital of Amravati. I'm giving a live example. This is a case study you can always ponder how it is important. Apart from that, we make slag cement also. It's a very good product, especially for the plastering applications, masonry applications, and even concrete also. If you're using the site mix concrete, highly useful. So advantages of GGBS over fly ash are many. Having a very good advantage because fly ash, as I told you, the amorphous content is very less. The reactive content, even though we have silicon dioxide SiO2 more than 50-55%, in that reactive component is only about 25%. That is the thing. Then the chemical composition. I have just given a comparison of oxides, cement clinker, GGBS, and fly ash. So we have this major component oxides: calcium oxide, silica, alumina, magnesium, ferrous. We can see how comfortably the GGBS slag matches with the clinker, including the calcium oxide content. So fly ash having lesser cementitious material, only less than 2%. So it will help you to a certain level. You can comfortably replace up to 25 to 30%. So apart from that, to develop low carbon concretes, we can use for block manufacturing. We can use for sheet manufacturing. So it is not that only concrete you have to use the low carbon materials. You can use it for the other supplementary materials also, like tile adhesives we have. There also we can use AAC blocks, concrete blocks, and other things. So we have got many codal approvals now. Even soil stabilization also, the slag has been very useful. Up to 15% we can make use the soil stabilization, backfilling and all, blend it and compact it. You will get the results. So we have done at various studies. IIT Bombay, we have done a study. This study is up to almost 1 year on M40 grade concrete. And we have measured the strength gain over 3 days, 7 days, 28 days, 56 days, 90 days, and 365 days. So we have got an excellent results. You can see that the results are very good, phenomenal. Flexural strength, then chloride migration, chloride efficiency we have done. So you can see higher the replacement of slag of OPC cement, and the coefficient of thermal coefficient, like migration coefficient, is very less, reducing. 50% replacements always they say ideal. Only for the mass concrete you can go up to 60%. So similar application, CRRI we have done a study, Central Road Research Institute, Delhi. There, this is for the PQC road concrete, where we have done a lot of study. There also they have recommended to adopt 50% of GGBS in the concrete matrix. We have many specifications, major specifications. So I'm not telling anything just orally. All these products have got specifications in major departments where we can adopt these products. Not only because of the cost effectiveness, but also because of the high performance, high durability, high strength. And these are all the hallmarks of cements as well as SCMs. These are all many major projects where are already adopted and using. So list of specifications, various codes also is mentioned, which are the codes referring to various specifications. We have mentioned everything here. IRC, BA specifications. You can go through that and refer it. And we have made environmental product declaration. Whatever products we are manufacturing, EPD. Now, EPD is a globally accepted standards. Even you go to any European country, they make it mandatory that you should have a EPD certificate for your product. That means how much carbon dioxide per ton you are emitting. This may vary plant to plant, location to location, but they want it. Then only they put a benchmark. Okay, you are making cement. Your carbon intensity should not increase so much. Otherwise, we will not buy from you. So the world leading cement manufacturing company, JSW, has become lowest carbon footprint company in the world compared to any other company in India, any other company in abroad. So this is the next best example, and I've just done a calculation how much emissions are coming down. So we have 100% OPC mix, 25% fly ash, 75% OPC, 50% OPC, and 50% GGBS mix. So in this mix of M40 grade concrete, you can say the fly ash mix, the CO2 emissions have reduced to 18%, whereas if it is a GGBS mix, emissions have been reduced to 42%. So that is a beauty. The difference between the OPC blended as well as GGBS blended is almost 29%. Similarly, various applications we can use ground on slab, early strength, up to 35% we can use. Underground concrete structures with average strength requirement, 50% we can use. Mass concreting application, 50 to 65% we can use. Like that. So many case studies are there here, like Bangalore Metro, where we completely did a study for M35 and M50 grade concrete. So any company, they want to adopt any system, they want a joint trial. The admixture company, cement company, chemical company, we did and proved to everybody that this product will work with all the cements, all the admixtures, so that you can adopt. These are the various elements, elevated corridor. You can see many structures. So this we have studied at one RMC plant called RMC Ready Mix India, where we have done a replacement almost for M20 grade concrete 60%. And you can see the OPC 120 kg, GGBS 180 kg. And after 28 days only, you have got a better strength. Okay. 56 days also it's increased. 90 days also it's increased. So that means to say that usage of mineral admixtures not only compromising the quality of concrete, strength on concrete, also achieves sustainability and durability. This is for M25 long-term strength. We studied up to 90 days. M30. These are the results of hundreds of trials, not one trial, two trial. Hundreds of trials we have made. Some of the living examples of the projects. Mangalore. Some of the photos all over India we have done. So I got Mangalore photos I'm having. This is Citadel, Mangalore. Because Mangalore is similar city like Vizag, coastal and similar culture almost. So one Vizag building, when I was coming here, I had taken this photograph also. Long back. Still it is there, luckily. Vizag photo is there. GGBS usage. And Mumbai Underground Metro Station. There the GGBS usage is 46%. In Bangalore International Airport, here also 40% of PQC concrete work. So Cable Stayed Bridge, Goa, you can see. There also the GGBS has been used up to 50%. I was talking about this project, the AP capital region, Amaravati. They used 60% GGBS. As I told you, the re-inspection was done to carry out the work. The new government assumed office and started working on the capital region. So definitely, you can see the foundation was very strong. Once again, Trans-Harbour Sealing Project, MTHL. Then we have Karwar Seabird Project. So here also L&T, initially they started with the 25% GGBS. They made 50% and 60%. So they got the confidence. So any product to be adopted, you need to have the confidence with you that it will work. So start with a lower percentage and keep on increasing and keep on doing it. That will help you. Once again, other projects like Amar Pristine project, many examples are there. I'm giving you how it is helping actually. So not only one project, there are hundreds of projects here in India where they have been using continuously. So microfine GGBS is a new product. This is ultrafine. You may be knowing this are microsilica or alcofine. This product is better performing than those products. Why ultrafine? Because you need a higher particle packing when you go for high grade of concrete. Because you need to attain the strength, quick strength. The moment you add higher particle, then you get a quick strength. So these are all products which are ultrafine material like microsilica, ultrafine GGBS, ultrafine fly ash, metakaolin. So availability is very important. Ultrafine GGBS is available in many parts of South India and Western India, North India, because companies are manufacturing now, and also the potential and quantity is going up. The advantages of ultrafine material is that the ultrafine GGBS or microfine GGBS gives better performance because the particle size is below 10 micron. So it's very reactive component. So product overview, how the ultrafine microfine GGBS will be manufactured. Similar way, when we get GGBS, we separate out material and have a separate crushing unit, and you will get continuous uniform structures, uniform products from that kind of a process, so that you get a very good quality ultrafine GGBS. BA certificate we have got. So advantages of ultrafine GGBS or microfine GGBS are many, especially quick strength, early strength for required for high grade of concrete. High performance because it's a slag based product, so reduced carbon footprint and durability is enhanced. So applications of JSW microfines are many. We have got raft foundation, mass concreting, grouts, geopolymer concrete, marine structure, high density. All the applications, if you're doing any R&D work, you can try out using this product. Very important. So use of JSW microfine in many projects used actually. So compared to microsilica, ultrafine GGBS is better. The microfine GGBS is better because of the this is a research work by IIT. So because the particle packing is very good. So many trials we have done, M50, M60, and M80 grade concrete. Everywhere the products have been very successful. These are some of the major builders who have been using this product. And also we give a certificate also. using JSW, GGBS or microfine, based on your consumption pattern, reduce carbon footprint, we are going to give a letter also. Some of the appreciation letters, many projects we have been doing. So this is the IRC code, RDSO, railways. So there also they have mentioned the usage of GGBS up to 50%. So what I'm going to tell you is that now adaptation of low carbon concrete is a must now for everybody. Very important to use blended cements. If you are buying concrete from RMC plant, you should ask him, GGBS are you using, fly ash are you using, how much percentage you have been using. You have to look into all these aspects when you want to buy a concrete, when you want to order a concrete to some customers. These are the various departments, various government agencies who have been using our product. RMC plants, once again, we have been catering to all the RMC plants across India. So sustainability initiatives by Indian developers. So green buildings are going to come. India is the fastest adopting country in terms of green buildings compared to any other country. It stands second only to America. Innovation and construction techniques is very important. We are bringing BREEAM and other alternative modules to work very closely in a challenging environment to get accountability in concrete construction. So energy efficiency and green technologies are very important. Renewable energy storage systems are coming. With all that, should be able to achieve that. So I would like to conclude my presentation. It's very important for the professors to adopt green solutions, not only at their construction sites, but also you have to advise the students and faculty and other members that they should adopt green technology, sustainable materials, and always innovate. Innovation is very important. Through innovation only we can bring in new technology and make India self-reliant. Jai Hind. Thank you.
Thank you, sir. Thank you for a wonderful presentation on moving towards net zero and concrete constructions. It was fantastic. It was forward-looking presentation. It's reassuring to hear about concrete-based solutions, aiming for net zero emissions, maybe 2050 or 2070, or what you have mentioned, sir. So it was really wonderful.
Yeah.
Sir, can we take questions, sir? A few questions.
Yeah, sure.
Yeah, first question is from Jhansi. She is asking, is JSW composite cement available in Andhra Pradesh?
Composite cement available, Karnataka, they made it available. Let me check and come back to her.
Okay.
Vizag, since we are far away from our plant is in Nandyal, it's a bit far away. I don't think so it's available there. I'll come back to her very soon.
I think she is using that for her PhD work, if I'm correct, sir.
Then we'll try to get our material somewhere arranged.
Okay. Right. Thank you. Next question, sir. Mahalakshmi Naidu, what is migration quotient?
What is?
Migration quotient. Migration quotient.
Migration coefficient.
Yes, sir.
See, migration coefficient is defined like, okay, the percentage of migration of the RCPT, chloride, okay, entering the concrete. So they'll measure, okay, what is the speed and how much percentage in particular time period will enter the concrete matrix. That is the migration coefficient.
Okay, sir. Mr. Giri, he is asking which Indian standard specifications specifies the use of GGBS slag in cement and concrete?
See, IS 456, there it is there. IS 455 for PSC cement. They are allowing up to 25 to 70%. Then we have a composite cement code.
Yeah.
In that code also, the usage of slag is mentioned. IS 16714 is also there. And I'm sharing the PPT. In that, what are the codes which are approving the IRC code, BIS code? Every code is mentioned there. IS 10262. All these things are there. I'm going to share it with all of you. That the list is mentioned there.
Okay, sir. Okay, sir. Yeah, any other participants, please, if you want to ask any questions, you can unmute your mic and ask it. Questions.
This PPT, I'm going to share it with you. Everything is mentioned there. You can check it.
Yeah, sir. Anyone from the participants? Any more questions, please? Okay. So my personal question is blended cements any, like, we have OPC 33, 43, 50, like that blended cements, any grading is being done, sir?
33 grade only. All the blended cement fall under 33 grade only.
33 grade only.
Yeah.
Okay. So this like fly ash, you have C and F, like that. GGBS also classification is available, sir. Something like.
In India, only one grade is there.
Only one grade. So
foreign countries, they have got 2 grades based on the reactivity.
Okay. Okay. Any more questions, please, from the participants? Okay, sir. Yeah.
So this recording is available?
Yes, sir. Recording is available.
Please
Sir.
share it with me. I'll share in my LinkedIn also.
Yeah, sure, sir. After completion of that, I'll share with you, sir. Okay, sir. Thank you very much, sir, for gracing this event.
It's my pleasure, actually. So anyway, my mobile number or any email ID is available to all of you.
Yeah.
You can interact with me anytime, any questions, any doubts are there. I'm always ready to support all of you.
Thank you, sir. Thank
you.
you.
Most of you are doing research work, PhD work, and students are doing PhD in concrete technology.
Yes,
so it's always better to interact and innovate. I can also share my new ideas and innovations.
Thank you, sir. Thank you very much for your kind words and support, sir. Aparagaru?
Sir, thank you, sir, for your very informative lecture.
Yeah.
Sir, just I have one question. Even the composite cement of Ma cement and other grades which are not readily available in the market, even in Visakhapatnam, until and unless you give a special order, they are not supplying. What could be the reason these composite cements are not available in the market in spite of their advantages?
You generally get slag cement in Vizag market. So composite cements are where the fly ash and the slag, both are available in those markets. They make composite cement. Okay. So,
but this, in the state of Orissa, these composite cements they are using very in use quantity, but in the Andhra Pradesh and other some of the states are not.
Correct. Everywhere it's not
aware about this.
Correct. We were the first to start composite cement. So we are also giving in particular markets and all. It become popular. Earlier, till last year, they are not allowed to be used in the concrete making, composite cements. Okay. So now it is allowed in the concrete making. That's the reason that more and more composite cements will come in the market.
That code is also available now, sir. So more awareness may be created.
Correct. Earlier, they are not allowed to be used in the concrete making.
Yes, sir.
Now they are allowed, so it will come in the market open.
Okay. Thank you, sir.
Thank you, sir. Thank you very much.
Thank you very much, sir, for your time and the information you have shared. Certainly, this information will be very useful to our PG students towards their MTech projects, and also some of the scholars also participating.
Good, sir.
Certainly, the contents you have delivered would be of useful, immense use to their.
My lot of articles are on ResearchGate. They can read, and also my LinkedIn profile, Dr. LRM. If they search, there are also a lot of articles I've published on durability, performance. So they can read all my articles. I keep publishing once in a week or once in a month new articles. So they can read all my articles also.
Sure,
Yeah,
sir. Sure, sir.
I just keep following your articles, sir, most of the time.
Thank you, sir.
Thank you, sir.
Thank you, sir. So please do visit, sir, to our college, because previously you regularly used to come to our college when you were
Yeah.
with Ultratech. Whenever you visit Visakhapatnam, please do visit our campus also.
Yes, sir.
Thank you.
Thank you, sir. Thank you very much.
Thank you, sir. Okay, can log off. Okay, thank you.
Yeah.
Thank you once again. Thank you, everybody. From the bottom of my heart, wish you Happy New Year to all of you. Very
Thank you,
nice.
sir.
Thank you, sir. Thank you. So, dear participants, I think we have come to the end of the program almost. So you need to fill the feedback forms, and then online test link will be shared in the chat box. Another 20 minutes time will be given. Just fill the feedback form and attempt the exam. And now it is 2:40. So 3:10 will be the cutoff time. So before 3:10, you are supposed to complete the exam, and you will reassemble at 3:10 for the validatory function. Yeah, two links are there. One is for the feedback. The second one is for the exam. So we'll assemble back at 3:10 p.m. Please.